ninth chapter, probability. This chapter belongs to Mathematics 2A, part 1. Today discuss definitions and introduction of the probability. First you goes to probability definition. First you learn a random experiment. What is the meaning of random experiment? In this random experiment means an experiment which can be repeated any number of times. If any experiment repeated any number of times under essentially identical conditions. In this essentially identical condition, you can experiment number of times. You can do that experiment, but essentially identical conditions, and which is associated with a set of known results. Which is associated with a set of known results. You know that the results and that experiment you can do that number of times, but essentially conditions only. That experiment is called random experiment. Thus, that experiment is called what here? Random experiment. After that, second one. What is the event? What is the event? Event is a combination of elementary events. Combination of elementary events in a trial or experiment. In a experiment, combination of elementary events in a trial is called event. In experiment, combination of elementary events is called event. Next one is exhaustive events. What is the meaning of exhaustive events? In this exhaustive events, the list of all elementary events. Here you can experiment a number of times. Number of events is coming. The list of all elements, all elementary events. That all elementary events in a trial is called list of exhaustive events. Exhaustive events nothing but a combination of all events. List of elementary events. That list of elementary events is called here exhaustive events. This is the random experiment. This one is the event. This one is the exhaustive event. Next, probability definition. What is the probability definition? If there are n exhaustive equally likely events. Equally likely events nothing but elementary events and events happening same way. That is called equally likely events. In this n are exhaustive equally likely events in a trial, and m of them favorable to on event A. Suppose n events are coming. In this n events of A, m events are favorable. M events are favorable in A, then m by n is called probability of event A. Here total events, n events are coming. In this n events, m events are favorable, then m by n is called probability of event A. This probability of event A is denoted with P of A. P of A nothing but probability of A. Is formula is number of favorable cases, nothing but outcomes, nothing but results. Number of favorable results or number of favorable outcomes or number of favorable cases with respect to A by number of all outcomes, all results, number of all cases of the experiment. This is a very important. This is a mathematical definition of probability. After that, the next point, the set of all possible outcomes in a trial. In a trial, the set of all possible outcomes is called sample space. In this sample space are denoted with the capital S. Capital S nothing but sample space. Next one, let capital S be a sample space of a random experiment. Every subset of S is called uneven. Every subset of X is called uneven. Every subset of S is what a sample set. Every subset of S sample sets is a even. After that, next point. Let S be a sample space. The event phi is called impossible event. Phi is called which event? Impossible event, and the event S is called certain event. Here S is a sample space. Phi is called empty. Empty set is called a impossible event. S is called certain event. Next point. Let S be a sample space. An event E in S. An event E is an event in S is said to be simple event if E. Simple event of E containing only one sample point. Only one which point here? Only one point, that is a sample point. These are the important points of the probability. Next point is two events A comma B in a sample space S. In a sample space, number of events is there. In that number of events, we have to take any two events. One is A, another one is B. If these two events are said to be disjoint or mutually exclusive events. Disjoint events also be called mutually exclusive events. If A comma B are disjoint events or A comma B are mutually exclusive events, then A intersection B value is equal to pi, nothing but impossible events. The intersection of two events having impossible event, that is called A comma B are exclusive events or A comma B are disjoint events. Okay, students. After that, next point. If two events A comma B in a sample space S is a sample space. In this sample space, number of events is there. In that number of events, you have to take two events A comma B. That A comma B two events are exhaustive events. Which events? Exhaustive events. If A union B, the combination of the two events equal to sample space. Here, A intersection B equal to pi. The intersection of two events are impossible. That events are called disjoint events or mutually exclusive events. If A comma B two events combination is sample space, the combination of A comma B equal to sample space, that events are called exhaustive events. Next point. Two events A comma B in a sample space S are said to be complementary. If two events are complementary events, that two events are mutually exclusive events and mutually exhaustive events. Understood or not, friends? Here, mutually exclusive events, that events are mutually exhaustive events, that events are complementary events, otherwise not complementary. That's why here A comma B are two events. Here A intersection B compulsory equal to pi, A union B equal to S. Here A intersection B equal to pi, that is mutually exclusive events. A union B equal to S, that is exhaustive events. These two conditions are possible, that two events are complementary events. The complementary of B of A is A complement or A complement or A bar. You can denote it with the complementer of A is A power C. A power C nothing but complementary, or A power bar. A power bar means what here? Complementary of A. Suppose B nothing but B bar or B complement. In these two events are complement, that two events compulsory, merchant should be mutually exclusive and exhaustive events. Next, Next point, let S be a finite sample space. What is the meaning of finite? Finite nothing but countable. Countable sample space. That events are countable. That is called a finite sample space. A real valued function P is a probability. Rho of S tends to R is said to be probability function. This function is said to be probability function. Three conditions must and should be satisfied. What is the first condition? P of A value is greater than or equal to 0. The probability of A is always greater than 0 or equal to 0. That is the first condition. Second one is the probability of sample space. Total sample space probability equal to 1. Third one is if A comma B belongs to rho of S, here compulsory that the two events are mutually exclusive events and the probability of that P of A intersection B is 0. Nothing but pi is not impossible event. Impossible event probability is 0. Next, P of A union B equal to A union B is what here? A union B is a combination of two probabilities, P of A plus P of B. Then P is called a probability function. And for each A belongs to rho of S and P of A is called a probability of A. This is a condition of P function probability. These three conditions. One is P of A is greater than or equal to 0. Second one is P of S equal to 1. Third one is P of A intersection B equal to 0. Next one. If A is an event in a sample space. A is an event and sample space. That A probability is lies between 0 to 1. The probability of any event lies between 0 to 1 and included 0 and included 1. That value lies between 0 to 1. That probability can be possible, otherwise the probability cannot be possible. That is impossible. This is the introduction of the probability. Definitions are explained and the formulas also be explained. Some conditions also be explained. Next class, discuss exercise 9A.